Bismillahirrahmanirrahim. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajmain. So this is the second last of our lecture, which is mobile network layer. We focus on mobile IP. In this lecture, right, we're going to discuss about the motivation of mobile IP, how the data transfer occurring in the mobile IP, and sort of one of the IPv6, how IPv6 is handling the mobile IP problem with the mobile IP, and some of the methodology of micro mobility support in the mobile IP. Right. This is the motivation for mobile IP. Why mobile IP is actually introduced is if we look at the static IP as before the mobile IP, there is a static IP, meaning static IP is attached to the particular device in the particular network. Okay? So IP is, all of you know, IP is a internet protocol, but here is referring identification of a PC or any devices in the network. Okay? So for routing, routing is based on IP destination address, which is you are familiar with the 109.13.40.42, which is that is as an example, which is determine the physical subnet in the network. Okay? So if you change the physical subnet, which imply changing of the IP address, and in order to do that, you have to have a correct topology. Otherwise, your routing table will not be useful to route data from the source to destination. Then other factors that motivate of introducing mobile IP is if you have the static IP, changing all routing tables entries to forward packet to the right destination. So at the end system, you always, if you modify it, then you have to change the routing table. And also it doesn't scale with the number of mobile hosts. So, and frequent changes in the location, which is occur, will introduce a security problem. So meaning that your routing table you always change. If you using the static, you always if there is another connection, you have to introduce, and then you have to create another IP in order to make the routing correctly in your network. Okay? And also changing the IP address, which is of course you adjust the host IP address depending on the current location. Almost impossible to find a mobile system. DNS update take too long time. So imagine if you don't have the mobile IP, the DNS always, if you change the routing table, updating the DNS domain name server is take sometimes. So what the consequences is, sometimes the TCP connection break, and this is also introduce a security problem where the the network will look at this one. Maybe there is attack if there is always the TCP connection break. So this is by implementing the mobile IP. Hopefully, this all and what we have currently right now, we already implement the mobile IP. Right. This is the requirement based on RFC 3344. Was 3222. You look at the RFC and was introduced in 2002. The requirement is first the mobile IP have to be transparent, where mobile end system or your devices keep their IP address as it is original IP, and all the communication as if this mobile IP is talking with their own IP, right? Without any interruption. And even you change the location, still there. So transparency meaning that, yeah, as if you're using it, your mobile, you bring your mobile IP. And also it need to be compatible with some layer 2 protocol as IP, and then no changes to the current end system and routing required. So if you bring your IP, the compatibility must be there. For example, if you move from for example, in FIT, you move to the faculty engineering, you still can bring your mobile IP. Regarding the security, also the same. Authentication of all registration messages, so meaning that the security must also support the mobile IP, because moving from one subnet to another subnet, or from one network to another network, will trigger the security problem. Because when you are in a network A, maybe you can access the certain resources, but when you move to the another network B, you maybe cannot access certain resources. This is security. So all this set need to be supported by the mobile IP. Efficiency and scalability, yeah. Only little additional message to the mobile system required. Connection typically via low bandwidth radio link. So this is need to be support, as the name is mobile IP. The movement, if you expand the concept of mobile IP, should be supported, right? Some of the terminology in the mobile IP you need to remember. This is sort of definition. So mobile node is MN. Mobile node is a system node that can change the point of the connection to the network without changing its IP address. So that is mobile node, basically your devices. Home agent, system in the home network, of the mobile network. Mobile node, typically a router, which is perform the register the location of the mobile node, and also doing the tunneling IP datagram to the care of address. Care of address, or COA. For the foreign agent, we can call it FA, is a system in the current foreign network. So we have the home network and we have the foreign network. Later on we will see this one on the mobile node. Typically a router forward the tunnel datagram to the mobile node. Typically also the default router for the mobile node, the current mobile node. Care of address is address of the current tunnel endpoint for the mobile node. It can be at FA or mobile node. Actual location of the mobile node from an IP point of view. So actual location of the mobile node from an IP point of view can be chosen via the DHCP, Dynamic Host Control Protocol. Corresponding node, CN, is the communication partner. I will see this one. For example, here, if you look at this one, let me get the ballpoint. Okay, this is imagine this is your network, home network. You are here, okay, and this is the mobile end system. Basically, mobile node here, MN, is actually currently at the foreign network. So we got home network and we got the foreign network. Okay, so let's look at the sequence. This is the sender. Okay, sender send the data to the mobile node. Okay, over here. But with this one, because the sender knows the IP address that is supposed to be at the home network. Okay, but currently the mobile node is moving to the other networks. What happened is, first, the current network, the counterpart network, which is sending the data to the mobile node, which is over here, because the IP here, and this is the home agent, because currently the mobile node is not there. They will tunnel the communication to the tunnel. The red one is tunnel the communication because one of the function of the the mobile node is home agent is to tunnel IP datagram to the care of address. Okay, so over here they will tunnel. Of course, before that there is a communication prior to that, the mobile node already informed the home address that mobile node is currently at the foreign network. So when the tunnel, and then this is the communication will be forwarded. Number two, home address, home agent, sorry, tunnels packet to the care of address, which is to foreign agent, which is in the foreign network by the encapsulation. So foreign agent forward the packet to the number three, forward to the current mobile node. Okay, that is how the data transfer. And when it's reply, because mobile node is upon receiving the data packet from the counterpart network, as we learned that there is what called destination address. So no need to go from here, from the front agent, and go to the home agent and forward to this. No need to go over there, because the communication, as you know, the destination, you just forward to the particular. So the mobile node, the sender, will send directly from the foreign agent through the internet, go to the counterpart network and to the particular sender. So that is the sender sends to the IP address on the receiving as usual. Foreign agent work as a default router. So this is the overview, which is the same like as I explained before. Okay. The network integration, meaning that before you have to have like this, actually there is a network integration to support the mobile IP. Agent advertisement, home agent and foreign agent periodically, meaning that in certain time, send advertisement message into their physical subnet. So they, like, there is a communication between home agent and foreign agent. And mobile node listen to this message and detects if it is in the home or in the foreign network. Okay, if it is in the foreign network, mobile node reads a care of address from the foreign agent advertisement message. And upon that, after listening to the agent advertisement, registration always limited lifetime. Right? Mobile node signal care of address to the home agent via the foreign agent. Home agent acknowledged via the foreign agent to the mobile node. This action have to be secured by authentication. So this is what called registration. Okay? And the advertisement, home agent advertise the IP address of the mobile node as for fixed system, instant routing information. Router adjusts their entries. These are stable for longer time, which is home agent responsible for a mobile node over a longer period of time. Packet to the mobile nodes are sent to the home agent, independent of changes in a care of address at the foreign agent. So that is the advertisement if you want to integrate. As for the mobile IP and IPv6, mobile IP was developed for version 4, which is 32 bits, sorry, and IP version 6 is about 128 bits, and then but IP version 6 simplify the protocol, meaning that IP, when you talk about mobile IP, that is for IP version 4. In IP version 6, actually they cover already the mobile IP. Security is integrated and not an add-on. Okay, authentication of registration is included, meaning that in IP version 6, you don't worry about the security because that is part of the IP version 6 packet. Care of address can be assigned via auto configuration. They call it DHCP version 6. Is one of the candidate. Every node has address auto configuration. So IP version 6 is auto configuration. No need for a separate foreign agent. All routers perform router advertisement, which can be used instead of special agent advertisement. Addresses are always co-located. So this one in the IPv6 because the size of address is quite big. Mobile node can signal a sender directly to the K of address. Sending via home agent not needed in this case. So mobile node can signal a sender directly to the K of address, not through the home agent anymore. Okay, there's also the soft handover, i.e. without packet loss between two subnet is supported. Mobile node send the new K of address to its old router. Then all router encapsulate all the incoming packet for the mobile node and forward them to the new K of address. Authentication is always granted. So basically, it's like the IPv6 is more simpler as compared to the IPv4 in terms of supporting the mobile IP. Right? When you implement mobile IP, of course, there's a problem. Yeah? Because the problem lies basically in the security. Because as I mentioned earlier, when you move from one subnet or to another subnet, or maybe that's not too critical. If you move from one network to another network, the level of access of that particular PC is different. So maybe if you are in the network A, you can access the data, the critical data when you are in the network subnetwork A. But when you in the network B, you might be a foreign. You might be like not like authorized device or person to access certain data. So this is what called security. So in terms of security, authentication with a foreign agent problematic. For the foreign agent typically belong to the another organization. So no protocol for key management and key distribution has been standardized in the internet. So patent and export restriction. So this is what I mentioned is different organizations have different called privacy or mechanism of different policy in order to provide the security. Another problem with the mobile IP to implement it is firewall. Typically, mobile IP cannot be used together with a firewall. Special setup are needed. Firewall is to detect any other malicious attack which does not belong to the network. It will what called block. So when you you bring your IP, you are become foreign to that particular network. So when the firewall see this one, so it seems like it's trying to hack the network, so it will cut. So that's why you need a special setup to allow the mobile IP. In terms of quality of service, many new reservation in case of RSVP. Tunneling make it hard to give a flow of packet. Special treatment needed for the quality of service. Yeah, quality of service when you move from one point to another point is very critical because you don't know how to manage the resources. Security, firewall, quality of service, etc. are topic of the current research and discussion. So yeah, if you are interested to dig more on mobile IP, you can look at the security of implementing the mobile IP. Right now is, for example, a head-up network. Still, the security is still open for research. This is we discuss about the IP micro mobility support. Micro meaning that in the small scale. Micro mobility support is very good, efficient, local, and handover inside a foreign domain without involving a home agent, which is that one is for micro mobility. Reduce control traffic on the backbone, especially needed in the case of routing optimization. This is for the micro, so it doesn't need or every time to communicate to the home agent. So example of the approaches you can implement using the cellular IP or SIP, Hawaiian hierarchical mobile IP or HMIP. What is the important criteria for the IP micro mobility support is in terms of security, efficiency, scalability, transparency, and manageability. And look at the SIP, so cellular IP, how they operate. If you look at the architecture there, SIP nodes maintain routing entries. Okay, for mobile nodes, SIP is maintaining the routing entry, and multiple entry possible. Routing entries update based on the packet sent by the mobile nodes. So SIP nodes maintain the routing entry. So meaning that every time the what called the routing locally will be updated based on the packet that's sent by the mobile nodes. So this one, for example, this is mobile 2. If mobile 1 communicate to the mobile 2, they will communicate based on the packet that's sent. It will not go over the another side through the CIP gateway. CIP gateway is mobile IP tunneling endpoint initial registration processing. So this one is CIP will communicate to the, if you can see over here is you've got home agent. So if possible, any communication over here that happen in this particular subnet will not go outside. So this is what we call managing the communication optimization within the micro mobility. About security provisions, all CIP nodes share network key. So all CIP nodes is sharing the network key. The mobile node key is using MT5 net key and IP address, and mobile node gets key upon the registration in that particular network. Right, the advantage of cellular IP is first, initial registration remove authentication of mobile nodes and is processed by the centrally by the CIP gateway. All control messages by the mobile nodes are authenticated. Replay protection using the timestamp. So replay protection is meaning that if there is any attack using the replay packet will be protected because in CIP they're using the timestamp, meaning that the packet that will be attached with the current time. So if you replay that packet, will be not valid because the time is invalid already. What is the potential problem in the cellular IP is mobile node can directly influence routing entries. Yeah, because as we look at the CIP, the what called the entries is updated based on the mobile network packet sent over the network. Network key known to many entries, yeah, because they are sharing. No rekeying mechanism for network key, so no choice of algorithm using the MT5 prefix plus suffix mode, and the proprietary mechanism, for example, IPsec, not using the IPsec. So. Right, that is the potential problem in the CIP security. Other issue, the advantage of the cellular IP is simple and elegant architecture, mostly soft configuration, integration with the firewall. So CIP can integrate with the, because there is a firewall. Potential problem, not transparent to the mobile node, additional control message, public key encryption of the mobile keys may be a problem for resource constraint. Yeah. So if you share, you have multiple path forwarding may cause inefficient use of the available bandwidth. Yeah. Right. Another mechanism is using Hawaii. Hawaii is the operation is the mobile node obtain co-located key of address. The mobile node obtain the key of address. This is number one over here through the DHCP. Okay, right. So handover meaning that handover moving from one base station to the another base station is they use the uh, registration. Mobile node keep the key of address, new base station BS answer registration request and update routers internally. Routers internally, and mobile node view BS as a foreign agent. Over here, the mobile node view this one as a foreign agent, but actually not. It's logically. So the routing will be updated over here. In terms of security provision, mobile node and foreign agent authentication mandatory. So they're using the challenge response extension mandatory. In the challenge response is meaning that if you send, like for example, what is your name, what is your password, then you type the password. That is what called challenge and response. The advantage of Hawaii security is mutual authentication and challenge and response extension mandatory. Only infrastructure component can influence routing entries. Yeah? So as compared to the CIP, the routing table or routing entries is influenced by the mobile node, but here not. The potential problem co-located or key of address raise DHCP security issue. DHCP has no strong authentication, just like here. So decentralized security critical functionality. So mobile IP registration processing during handover in the base station. So authentication of Hawaii protocol message unspecified. So this is the in terms of the problem, security problem happen in the Hawaii. So for the mobile node authentication require PKI, public key, or AA3 AAA infrastructure. Advantage of using the Hawaii is more transparent as mobile sends and receives standard mobile IP message, explicit support for dynamically assigned home address. Potential problem is a mixture of a co-located key of address and foreign address concept may not be supported by the some mobile network implementation. No private address support possible because of the co-located address. Okay, we have talked about the cellular IP and Hawaii, and this is the another approach of the hierarchical mobile IP version 6 or HMIP version 6. How they operate is network content mobility anchor point, or they call it map. Okay. So map is mapping of the regional key of address, RCOA, regional, to link with the K of address or LCOA. That's the function of the map. For the handover, mobile nodes inform the map only. So so what happens is the map will get new local new link key of address and keep the regional key of address. Home address is only contacted if map changes. So if map changes, then it will consult the home address. Okay, again, don't be confused. This one is only for micro mobility within that particular network. We are talking about the how to optimize the movement of the mobile nodes in the foreign network in that particular network only, micro. Security provision, no hierarchical mobile IP specified security provision. Binding updates should be authenticated. So only based on the binding, this is considered as a security point for the uh, HMIP. The advantage in terms of secure advantage of the HMIP is local key of address can be hidden, yeah, which provides some location privacy. Direct routing between counterpart network sharing the same link, it is possible, but might be dangerous. Why? Because yeah, you don't know who is contacting because it's the uh, uh, the key of address is hidden by the network. The potential problem, decentralized security critical functionality, especially during the handover processing in the mobility anchor points in the map. So mobile node can or must directly influence routing entries via binding updates. Right. The advantage is another advantage of the MIPS handover requires minimum number of overall changes to the routing table. So integration with the firewall and private address support possible. It's possible to support this when you integrate with the firewall. The potential problem, not transparent to mobile node. Yeah, as you can see the binding. Yeah. Handover efficiency in wireless mobile scenarios, very complex, and all routing reconfiguration makes sense over the wireless link. So, thank you for that. That is the lecture on the mobile IP. Hopefully, you can review. If you don't understand, you can refer to the slide and then refer to the other notes and discuss about the mobile IP. Thank you very much.